40 tons of American-built fury on steel tracks wider than a man is tall. The Washington Skagit Yarder didn't ask permission from the wilderness. It demanded submission. This machine could drag a 200-foot Douglas fir up a mountainside using nothing but cable physics and violence, could pull loads that weighed more than 5 elephants through terrain that would swallow a modern truck whole. This was 1,920 seconds Pacific Northwest logging, and the Skagit Yarder was the apex predator of an industry built on conquest. Picture a machine the size of a small building. Steel frame 30 feet long, 12 feet wide, sitting on crawler tracks that distributed its massive weight across ground that fought back with every inch. Mounted on that frame was a vertical boiler 8 feet tall, a smokestack belching coal smoke into Douglas fir canopy so thick it turned noon into twilight. Next to the boiler sat 3 massive drums wrapped with thousands of feet of steel cable, and controlling all of it, converting superheated steam into mechanical destruction, was a donkey puncher who couldn't see what he was pulling but had to feel it through 2 miles of cable and 30 years of instinct. This wasn't your grandfather's steam donkey. The standard yarders could pull timber a few hundred yards. The Skagit could reach over a mile into forests that had stood untouched since the Pleistocene. It didn't gather logs, it conquered mountains. It pulled turns of timber that weighed 80,000 pounds up slopes so steep you couldn't walk them without grabbing trees for balance. Cost more than most men would earn in 10 lifetimes. And the crews who ran it, they had one rule that kept them alive. Feel the tension wrong and someone dies. Usually you. Today we live in a world of GPS-guided harvesters with climate-controlled cabs and automatic safety shutoffs. We've got machines that can fell, delimb, and buck a tree in 90 seconds, while the operator sips coffee and watches backup cameras. We measure danger in ergonomic assessments and OSHA compliance audits. But there was a time, not even a century ago, when American timber came from men who worked in conditions that would generate 47 lawsuits before lunch. This is the story of the Skagit Yarder, the iron beast that turned ancient forests into board feet, and the generation of men who fed it trees the size of buildings, knowing full well the machine had teeth and it was always hungry. Let's set the stage, because understanding the environment is understanding why this machine had to exist. The year is 1925. America is building everything. Cities exploding upward. Railroads spanning continents. Factories demanding lumber for crates, scaffolding, frameworks. Every house, every barn, every telegraph pole comes from a tree. And the biggest, straightest, most perfect trees on earth stand in the coastal ranges of Washington and Oregon. Douglas fir 300 feet tall, western red cedar 20 feet across at the base, Sitka spruce on the coast standing like wooden gods, their roots spreading through soil that had never known steel. These weren't trees, they were living monuments. Some had been growing since before the Magna Carta was signed. The forests were so dense you couldn't see 50 feet in any direction, so dark at midday you needed lanterns to work. So wet that moss hung from every branch and the ground was perpetually saturated, treacherous, ready to swallow equipment and men without warning. No roads, no towns within 30 miles. No way to call for help if something went catastrophic. Just the forest, the machine, and the crew. The standard steam donkeys couldn't touch this timber. Too small, too weak, built for a different scale of tree entirely. The logging companies stared at billions of board feet of the finest timber on the continent and realized their equipment was useless. So Washington Iron Works in Seattle built something bigger. Not incrementally bigger, revolutionarily bigger. The Skagit Yarder could do what shouldn't have been physically possible with steam and steel alone. Here's what made it different, and this is where engineering meets brutality. The machine itself was a monument to American industrial might. Twin vertical boilers on the heavy-duty models, each one 8 feet tall and 4 feet in diameter. Made of riveted steel plate half an inch thick, those boilers could maintain 200 pounds per square inches of steam pressure all day, every day in conditions that would destroy lesser equipment. The firemen shoveled coal constantly, sometimes a ton per shift, keeping the fires hot enough that the fireboxes glowed orange through the loading doors. That steam drove 3 separate systems: the main drum for pulling logs, the haulback drum for running cable back out to the woods, the straw line drum for lighter rigging work. Each drum was 6 feet in diameter and 8 feet wide, capable of holding 5,000 to 8,000 feet of cable. That's over a mile of steel rope per drum. The cable itself was 1.5-inch plow steel, each strand capable of holding tens of thousands of pounds before it screamed and snapped. The power transmission was pure mechanical violence. Steam drove pistons 12 inches in diameter with 14-inch strokes. Those pistons turned a crankshaft that engaged a massive gear reduction system, spur gears 6 feet across with teeth thick as your wrist. When those gears turned, they converted high-speed piston motion into low-speed, high-torque rotation. The drum speed under full load was maybe 15 revolutions per minute, but the pulling force exceeded 100,000 pounds. That's 50 tons of pull. Enough to uproot stumps, enough to drag entire hillsides worth of timber. But the real innovation was the high lead system, and this is where the Skagit separated amateurs from professionals. Traditional ground lead logging dragged timber along the forest floor. Logs hung up on stumps, dug into mud, destroyed everything in their path. The high lead system went vertical. They'd select the biggest, straightest tree in the setting, a spar tree that might be 200 feet tall and 6 feet thick. Then they'd send a climber up. The high climber was a special kind of insane. This wasn't recreational tree climbing with safety harnesses. He wore climbing spurs, sharp steel spikes strapped to his boots that he'd drive into bark. He'd flip a belt around the tree, basically a rope or leather strap, and shimmy up, stab, and pull. Stab and pull. One slip, one rotten section of bark, one moment of lost concentration, and it was a 200-foot fall with nothing but physics to stop you at the bottom. He climbed carrying his saw, his axe, all his tools strapped to his belt. When he reached the topping point, maybe 150 feet up, he'd make an undercut on one side, then a back cut, just like felling a tree on the ground. Except he was doing it suspended in the air, standing on spurs, with nothing but a belt keeping him attached to a tree he was actively cutting. When the top fell, and it fell with spectacular violence, crashing down through surrounding timber, the entire spar would whip back and forth like a fishing rod. The climber just hung on, riding it out, waiting for oscillations to die down. Once the spar was topped, the rigging crew installed blocks at the summit, heavy steel pulleys that would guide the cables. Getting those blocks up there was another adventure involving lighter lines pulling heavier lines, pulling the actual block. Hand over hand, 150 feet of vertical lift done with muscle and manila rope. Now, when the Skagit pulled, the logs lifted off the ground completely, swinging through the air like pendulums of death. High-lead logging was faster, cleaner, more efficient. A good crew could pull timber from terrain that ground lead couldn't touch. It was also exponentially more dangerous because now you had logs flying through the air 40 feet off the ground, swinging on cables under incredible tension. If a choker failed, if a cable snapped, you had tons of wood falling from height, crushing anything underneath. And please hit that subscribe button. It really helps the channel grow and lets me keep bringing you these stories of America's industrial giants. The crew structure was rigid, hierarchical, based on competence because incompetence got people killed. At the top was the donkey puncher, the man who operated the Skagit. He sat at the controls with hands on friction levers that controlled steam flow to different drums. He couldn't see the logs, couldn't see the crew, worked entirely by whistle signals and by feel. He had to know his machine like a surgeon knows anatomy. Had to feel tension in the cable through vibration in the levers. Too much tension and the cable snaps. Too little and the log doesn't move. The whistle punk was usually the youngest guy, 16 or 17 years old. He stood near the logs being rigged with a wire that ran back to the steam whistle on the yarder. One whistle meant stop. Two meant go ahead slow. Three meant go ahead fast. A long, continuous blast meant emergency. Someone's hurt or trapped or dead. The entire operation, men's lives, success or failure of the pull, depended on a teenager yanking a wire at the right moment. The choker setters were the most at risk. They ran out into the brush, wrapped steel chokers around logs that might weigh 40 tons, signaled the whistle punk, then got clear before the cable came tight. They worked in chaos. Terrain covered in slash and broken branches, limited visibility, the cable running toward them like a steel snake. They had to grab it, maneuver it around massive logs, set the choker, and clear out before the pull started. Slip, get caught, log rolls, you're done. The rigging crew boss calculated everything in his head. No calculators, no engineering software, just experience and intuitive understanding of forces, angles, breaking points. He positioned the blocks, set the anchors, determined the mechanical advantage needed for each pull. Set the rigging wrong and you wasted a day repositioning. Set it catastrophically wrong and you killed someone when an anchor point failed and thousands of pounds of tension released instantaneously in the wrong direction. Let's talk about where this machine worked, because the environment was designed to kill you. The Pacific Northwest logging country was steep, wet, isolated. Crews worked in the Coast Range, the Cascades, the Olympic Peninsula, miles from the nearest road, 50 miles from the nearest town. Supplies came in by riverboat or pack train. If something broke, you fixed it with what you had or you shut down the operation and lost the contract. The camps were temporary. Bunkhouses built from rough-cut lumber, no insulation, bunks stacked 3 high. Men slept in their work clothes because the cold came through the walls like the walls weren't there. Winter temperatures in the mountains dropped below freezing. Summer heat inland hit 100 degrees. It rained constantly, the kind of rain that soaked through wool and canvas and never let you dry out. Your clothes rotted on your body. Your boots fell apart. Trench foot was common. Respiratory infections from sleeping in wet clothes in unheated bunkhouses killed men as surely as the machinery. The forest itself fought back. The ground was soft, centuries of decaying vegetation creating a spongy layer 6 feet deep in places. The Skagit sat on massive crawler tracks to distribute weight, but even then it sank. Moving the machine required jacking it up, sliding timbers underneath, winching it forward foot by foot using its own power. The trees didn't want to move either. Douglas fir weighs more per cubic foot than most hardwoods. When a 150-foot log hit the ground after being felled, it buried itself in soft earth. Getting it rigged required blocks, cables, smaller donkeys, and pure stubbornness. Disease lived in that environment. Dysentery from contaminated water, typhoid. Influenza spread through cramped bunkhouses like wildfire. Get sick, and you worked through it, or got fired. No paid sick leave. No workers' compensation. Get hurt or sick, and you were on your own. Men died from infections that modern antibiotics would clear in 72 hours. A cut turned septic. Sepsis turned to blood poisoning. Blood poisoning killed you slowly, painfully, and there was nothing anyone could do except watch. The isolation was absolute. No way out except the way you came in, usually a 2-day walk minimum. They wrapped bodies in canvas, sent them downriver if there was a river, buried them in unmarked graves if there wasn't. The work continued the next morning because the forest didn't care and neither did the company. Now the danger, because operating a Skagit yarder was statistically more dangerous than combat infantry work. The boiler was a bomb. Working pressure was 200 pounds per square inches. Safety valves were supposed to release at 180, but men being men and quotas being quotas, operators sometimes tied down safety valves to get more steam. More steam meant more power. More power meant bigger pulls. The boiler didn't care what you called it. Push it too far and the seams split. When a steam boiler fails, it doesn't leak. It explodes. Superheated steam at 400 degrees doesn't burn skin, it flash boils the moisture in your body, strips flesh from bone in seconds. There's a story from the Olympic Peninsula, 1923. A Skagit was running hot, pulling a particularly massive turn of old-growth cedar. The pressure gauge was reading 210. The donkey puncher wanted one more pull before shutting down for the day. The fireman knew better but did it anyway because saying no meant getting fired. The firebox seam let go. The explosion peeled the side of the boiler open like a tin can. The fireman took the full force of the steam cloud. His lungs were scalded from the inside. They didn't recover enough of him to bury properly. The company sent a telegram to his family, brought in a replacement fireman within 3 days. The work continued. The cables were another constant threat. When a cable breaks under full tension, it recoils at speeds faster than you can process. The physics are simple and brutal. Thousands of pounds of stored energy released instantaneously in a direction you couldn't predict. A choker setter named Murphy was working near Longview, Washington in 1926. The main line was under full load, pulling a turn up a steep grade. The cable had been showing wear for a week. Murphy reported it. The rigging boss said they'd replace it next week. The cable parted halfway up the slope. One end whipped back toward the yarder. The other end whipped forward toward Murphy. He never saw it coming. The cable caught him at chest level, traveling close to 100 miles per hour, cut him nearly in half. He lived for about 20 minutes, conscious most of it. They carried him to camp, but there was nothing anyone could do. They found pieces of the cable embedded in trees 30 feet from where it broke. The company replaced the cable. The work continued. What happened when men fell into the machinery? The gears on a Skagit weren't enclosed. Everything was open, exposed, accessible for maintenance, but also accessible for accidents. The main drive gears were 6 feet across with teeth 4 inches long. Those gears turned slowly, maybe 20 revolutions per minute under load, but they turned with unstoppable force. There was a man named Kowalski, an oiler on a Skagit working out of the Cascade foothills around 1924. His job was to keep the gear teeth lubricated with heavy grease while everything was running. Shut down every time you needed to grease and you'd never meet quota. So you greased it live. Kowalski slipped. Wet plank, moment of inattention. His sleeve caught in the gear teeth, pulled him in. The gears didn't stop, couldn't stop, too much momentum. They crushed his arm to the shoulder before someone hit the steam shutoff. The camp medic did the amputation with a hacksaw and a leather belt to bite on. No anesthetic except whiskey. Kowalski survived, went back to work 6 weeks later doing a different job. One-armed men could still tend fires or signal. He worked in the woods for another 12 years. Never complained. The noise was a weapon. The Skagit generated continuous sound levels that would violate every modern standard. The steam exhaust was a constant roar. The gears meshed with a grinding shriek. Cable running through blocks created high-pitched screeching as steel scraped steel. The boiler hissed and clanked and groaned. Men went deaf. Not occasionally, routinely. By the time a donkey puncher hit 40, he was reading lips more than hearing words. But the real test came when impossible pulls happened. The turns that shouldn't have been possible. Logs too big, distance too far, terrain too steep. That's when you found out what the machine could do. More importantly, what the men could do. There's a story from the Olympic Peninsula, winter of 1927. A crew was working deep timber, Douglas fir and Sitka spruce, that had been growing since before Europeans discovered the continent. They'd been yarding logs for 4 months without major incident. The Skagit was a Washington Iron Works heavy-duty model sitting at the end of a skid road that ran nearly a mile into the forest. The turn they rigged that day was 18 logs, each averaging 25,000 pounds. Total weight approaching 225 tons. The terrain was steep, 35-degree slope. The donkey puncher was a man named Sullivan, 45 years old, had been running steam equipment since he was 18. The whistle punk gave the signal. 2 whistles. Pull. Sullivan opened the throttle. Steam pressure was at 195. The pistons drove. The gears turned. The drum began to wind. The cable went tight, and nothing moved. The logs were locked. Wedged against stumps, sunk into soft ground, fighting every law of physics to stay put. Sullivan could feel it through the controls. The engine was pulling, but the load wasn't moving. He had a choice. Back off and re-rig, which would cost the entire day, or give it everything the machine had. He pushed the throttle wide open. The boiler was screaming, safety valve blowing off steam in a constant roar. The cable stretched, steel rope loading to its absolute limit. Every man on that crew knew what could happen. If the cable snapped, the recoil would cut through the forest like a scythe. If an anchor point failed, the spar tree itself could come down, killing everyone within 100 yards. But backing down meant failure. And failure wasn't in the vocabulary. Then the logs moved. Not smoothly, not easily. But they moved, first one breaking free. Then another. Once they started sliding, momentum helped. The turn began to ride the slope. Greased skids, reducing friction just enough. Sullivan throttled back slightly, maintaining steady tension, feeling the load through miles of cable and decades of experience. The pull took 3 hours. When the turn finally reached the landing, the entire crew gathered to look at it. 225 tons of old-growth timber pulled nearly a mile up a mountainside through forest that fought them every foot. The Skagit sat there hissing and steaming, looking exactly like what it was, a weapon America had built to conquer wilderness. The landing itself was another critical piece. This was where logs arrived after the long pull, where they were unhooked, sorted by size and quality, and loaded onto railroad cars or sent down log flumes to the river. The landing crew worked with cant hooks and peavies, long poles with hinged metal hooks used to roll and position logs. A single Douglas fir log weighing 30,000 pounds doesn't roll easily. Men had to guide it using leverage and timing. Miss your timing and the log rolled over you. Happened regularly. A man named Chen was working a landing near Olympia in 1925, positioning a particularly large spruce with a cant hook when the log shifted unexpectedly. Rolled onto his leg, shattered the femur in 3 places. They freed him by lifting the log with another log used as a lever. Took 8 men and 15 minutes. By then the damage was catastrophic. Compound fracture, bone protruding through skin. He died 2 days later from infection. The landing didn't shut down. The logs kept coming. Someone else took Chen's cant hook and the work continued because stopping meant the entire operation backed up and nobody got paid. There was an economic reality driving every decision. A Skagit yarder cost $15,000 in 1925. That's roughly $250,000 today. The company that bought it expected return on investment. That meant running the machine every day conditions allowed. Rain didn't stop it. Cold didn't stop it. Only catastrophic mechanical failure or weather that made operations impossible stopped it. The contracts were brutal. A logging company might bid on a timber section with a deadline of 8 months to clear it. Miss the deadline and penalties kicked in. The company lost money. When companies lost money, heads rolled, foremen got fired, crews got disbanded. Men found themselves unemployed in camps 50 miles from anywhere. So corners got cut. Safety valves got tied down. Worn cables stayed in service longer than they should. Men worked injured because admitting injury meant losing your job. The machine became everything. Feed it, maintain it, run it until something broke or someone died, then fix what broke, replace who died, keep running. The supply chain was its own nightmare. Every piece of equipment, every gallon of fuel, every pound of food had to be hauled in. River barges bringing coal, pack horses with parts. Break a critical component and you were down until replacement arrived. Could be a week, could be a month. Some camps kept blacksmiths on site who could fabricate replacement parts from scrap. The men who worked these camps weren't just loggers. They were mechanics, blacksmiths, engineers, riggers, Problem solvers who could keep complex steam systems running with improvisation when actual parts weren't available. That skill set is gone now. We've specialized and credentialed everything to the point where basic mechanical competence is rare. The machines themselves rarely survive. Most were scrapped for steel during World War II. The few that remain sit in museums, slowly rusting into history. You can walk up to these survivors and touch them. Run your hand along the drum where miles of cable once wound. Look at the boiler and imagine feeding it coal in 100-degree heat. Stand where the donkey puncher stood and try to picture making life or death decisions based on tension you couldn't see. We don't build machines like this anymore, not because we can't. The engineering is straightforward. We don't build them because we don't need them. Modern logging is mechanized, regulated, safe. Feller bunchers can drop and process a tree in seconds. Forwarders carry logs without cables. It's more efficient, absolutely safer. Also completely disconnected from the raw physical reality of moving 30,000 pounds of Douglas fir through forest that hadn't been logged since the Pleistocene. There's something lost in that disconnection, not the danger. Nobody mourns crushed limbs and boiler explosions, but the directness, the absolute requirement for competence and courage. The knowledge that your skill and the machine's power were the only things standing between success and catastrophe. The infrastructure they built remains. The lumber that came out of those forests built Seattle after the fire, built San Francisco after the earthquake, framed houses in every town from Portland to San Diego. The wood is still there in buildings over a century old, as solid today as when it was milled. The men who cut it and dragged it and died doing it are mostly forgotten. Their names appear in company ledgers if they appear at all. No monuments, no plaques. Just the wood itself, still holding up structures they never saw, supporting people who never knew their names. Sullivan ran that Skagit for another 8 years, survived work that killed younger, stronger men. Retired in 1935 with hearing damage, a limp from a cable accident, and a pension of $45 a month. He lived another 18 years in a small house outside Seattle. Never talked much about the woods. Men from that era didn't. The Skagit he operated was scrapped in 1944, melted down for steel to build destroyers. The machine that conquered American forests became part of the machinery that won a war. Perfect symmetry. American iron, American timber, American men. The era of the timber killers is over. The machines are silent. The forests have grown back, though not with the giants that once stood there. The men are gone, taking their knowledge with them. But the legacy remains in every wooden structure, every board foot of timber, every city built from trees that took 5 centuries to grow and 5 minutes to fall. They were iron men with iron tools doing iron work, and will not see their like again. The world is softer now, safer, cleaner. Maybe that's progress. But every structure built from Pacific Northwest timber is a monument to what it cost to get here, to the 40-ton machines that devoured entire forests and the men who fed them, one impossible tree at a time.